Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, today we have a special guest with us. It's Ben Redwood, who's the Director of Supply Chain at 3D Hubs. Ben, could you tell us a little bit about what you do?
Of course I can. So I am the Director of Supply here at 3D Hubs, and my job is to look after our large global distributed manufacturing network. So a little bit different to our traditional supply chain, where companies would come along and actually have an inventory, and they would make sure that their inventory is up to stock and there's everything they need to be able to manufacture their product, make sure that pricing's on point and that they're on budget, and work with their suppliers to kind of negotiate lead times and pricing. We do things a bit differently. So we don't know what we're going to be making next week. That's the difficult thing for 3D Hubs. And so to do this, we have to have a large supplier network of manufacturing partners who have a large range of technologies and materials available, so that no matter what our customers come to our website and order, we have it and it's ready there to go into production. And that's probably a little bit of the change of supply chain. And that's where we're kind of seeing the future of manufacturing heading.
Very cool. And so for those of us who don't know, could you tell us a little bit about what 3D Hubs does?
Yeah, so 3D Hubs is a distributed manufacturing platform, and we are all about online manufacturing. So we're coming up on 6 years old. We're still a startup, or we think we're a startup. We've got the culture of a startup. We're about 60 people now. And we're probably more in the awkward teenager phase of being a startup. So we've grown out of being babies, and now we want to be the big boys in the game. And then we're looking at everyone with their IDs walking into all the bars, and we're saying that we want to be that soon. We're going through kind of a big growth phase at the moment, which is really exciting for us. But what do we do besides all this jargon? So basically on 3D Hubs, we are a whole network of manufacturing partners all around the world. And what we allow customers to do is come to our website with a 3D file, and this is a requirement for 3D Hubs. We don't produce the file for you. Upload it into our checkout, and we'll instantly show you a price. We'll instantly show you some manufacturability feedback, and with the click of a button, your part will be sent off to one of our manufacturing partners anywhere in the world and go into production within a few minutes. So we're really reducing the time that it takes engineers, product designers, purchasers to go out and negotiate with suppliers and find parts. And we're doing this whole new industry in manufacturing, which we're calling distributed manufacturing, that allows things to happen as easily as ordering a pair of shoes on Amazon.
So wow. You didn't start out, correct, doing exactly what you're doing now. You had more of a 3D printing focus. Is that accurate?
Exactly right. So I think the key in success to most good businesses is that your mission statement remains the same, right? From day one. And our mission statement has always been to make manufacturing easy and accessible for everyone. And when we launched back in 2013, our two co-founders saw that one of the easiest ways to get manufacturing online was actually 3D printing. So they came from the 3D printing industry. They had a lot of experience with 3D printing. And with a bit of good timing, actually, they saw that there were a lot of patents that were about to expire in the 3D printing industry. And they predicted there would be an explosion of desktop printers onto the market. And they predicted this correctly. At the same time, two little companies, maybe you've heard of them, Airbnb and Uber, were doing this new model called distributed services.
I have not heard of them, but let's continue.
Yeah, exactly. Okay, you and my nana are about the only two people in the world, James. And so we said, well, how about we apply this to manufacturing? So the distributed service model essentially works that a company doesn't own any of the services it provides. It just facilitates the transaction between a supplier network and customers. So Uber don't own any cars. Airbnb don't own any hotels. Alibaba don't own any manufacturing shops. All they're doing is basically facilitating this transaction. And so applying this to manufacturing is something that's brand new, very disruptive, very exciting. And that's really how 3D Hubs launched and was conceived. But we were really focusing on the 3D printing market originally. And 3D printing was a very sexy topic in 2013. People were keen to get their hands on the parts and see what the hype was all about. And so we had explosive growth. We built a very large community of 3D printing suppliers all throughout the world. We used to have all these awesome marketing taglines like, we're in more countries than McDonald's, plastered across our website, or putting 1 billion people within 5 kilometers of a 3D printer. These kind of really cool things where we really just made the technology accessible. And it was probably quite difficult and expensive to get your hands on it using a traditional method. with 3D Hubs, you could just come on, upload your file, couple of clicks, and the part was getting made. And often people would actually go down to where the supplier who was just next door to their house and pick up the parts themselves, or jump on their bike and cycle around and meet the person who'd printed their parts, shake their hand, go inside for a cup of tea, see the 3D printer that had actually built it for them. So there was this real community aspect about it. And then a couple of things happened for us at 3D Hubs. So number one, 3D printing as an industry matured quite a lot. And the result of this was that a lot of professional players and big industry players came into the market wanting to get 3D printed parts for prototyping or production. And with 3D Hubs and the large market share that we had, we were one of the first places they engaged. When these people came to our website, they had a raft of new requirements that really didn't suit our old model, where kind of you'd share your stories over a cup of tea and ship the parts to someone in a cornflakes box. These kind of things really didn't match for us. And so these new customers really required a standardized experience with certification. They needed invoicing procedures. They needed all these things that our network wasn't able to do. And as more and more of these customers started coming and bringing these requirements and coming with more money and a much higher spend, we said, you know what, maybe it's time that we really listen to these new customers and make this transition to fit this new audience and to fit exactly what they're after. So we did a bit of a transition to a B2B model, and that happened late last year, and that's been something that's been very, very successful for us. So yeah, I think that transition of 3D printing maturing and us moving away from that kind of hobbyist maker scene and really focusing on the high-end customers has been something that's been very successful for us. The other thing that happened was that our customers also asked us, well, we really like the 3D printing experience, but we want other technologies. How can you help us there? Are there other things you could do? And I think the good sign of any startup is that you're scalable and you can automate a lot of things very quickly. And so we could add new technologies like CNC machining and injection molding quite easily and roll those out.
Now, we know a little bit about software or platforms that go from hobbyists to a little bit more B2B from some of the work we've done. But what kind, so you don't have the community aspect any longer, right? And
No,
I
we do
guess, okay, so why is it that we cut that off altogether instead of maybe like letting that run since it had the infrastructure and just focus on B2B?
Yeah, I mean, that was a very clear decision for us. And I think we have a lot of pride in the community that was with 3D Hubs and how we built that up. But we gave a lot of people the opportunity to join into this new platform. They had a set of requirements they had to meet, being a registered business, having a shop front, all these types of things were in the mix. And on average, we were sending about one 3D print a month to our entire huge community, which was encompassed about 31,000 printers. And so we said, right, a key part to people having a good experience as a supplier on 3D Hubs is they get regular business and they're actually really engaged with the platform. And so, yeah, this transition really focused on the people who were serious and really wanted to work with us. And then we set up a place called Talk on our website as well, where all the hobbyists and makers could kind of interact as a community there and then source their parts that way.
Do you, one more, Luke, sorry.
Shoot.
Do you still get a lot of hate mail because of that?
No, not at all. I think
that's great.
People, yeah, it is very good. I think at the time when we made the big announcement, a lot of our community were kind of expecting it. We'd made some changes on our website. We'd introduced what we called our manufacturing partner program, where our top performers were getting priority on orders anyway. That's not to say that people were certainly not happy with the move, but for us, it's been something that's been very successful. And unfortunately, this is the nature of the game. And there are some really great alternatives out there for what 3D Hubs used to be online that really have that community feel. It's just not our business model anymore.
Yeah, so side note, James and I totally missed the boat on this with having printers. So James and I could have been partners with this. Unfortunately, the 2 printers that 3D printers that we purchased, I believe mine has been broken for about 2 years now. What about yours, James?
I think it was only about a year and a half it's been down now.
Yeah. And
you're sitting next to me.
And the company went out of business, unfortunately, and they were like super unique custom parts on it that I just can't order anywhere. So
yeah,
I got a big paperweight in my closet.
I mean, when I say the 3D printing industry matured, this was a big part of it. Like if you really go back to when you guys purchased your 3D printers, it was Maker, it was knowing exactly to the nearest degree what to print your material at, and then spending hours with a chisel and hammer trying to get that print off the print.
Oh, yeah.
We've got the brand new Ultimaker in our office, and it is all wirelessly done, and you just click a button and it just produces the most incredible parts every single time. And that's just the expectation of the industry now. That's what people want, and that's what the majority of our network's made up of. These high-end brand new printers that are just really reliable and repeatable. And that's why, I mean, the statistics show 75% of all automotive companies now utilize 3D printed parts for production. I mean, it's a really cemented industry, and it's really having an impact on production now.
You see, he's coming up with new taglines instead of "in more countries than McDonald's." Now it's 75% of automotive. I like it.
I started my life in marketing like you guys now, you can't teach an old dog new tricks.
So I have a question. I'm on your website, and I'm wondering how often. And I don't know if you can share this or if you want to share it. So it looks super easy, right? 3 steps: upload the design, specify the requirements, get the part. Up to 2 days later, potentially, depending on quantity and location. How many times? Because James and I are both from the CAD world. We've both made models, 3D models our entire lives.
And bad ones, too.
Yeah, mostly bad ones. And I can only imagine how terrible models you potentially get sometimes. What percentage would you say go through without like your software, your geometry analyzer saying, yeah, this thing isn't going to work. You got to send it back? Because I would think that would be one of the most common challenges that someone using your service would use, is they don't necessarily know the manufacturing method, but they want to just get this part out there and they totally made it the wrong way. So how does that, number one, how does the geometry analyzer work, and how often does stuff go back? So 2 questions.
Yeah, cool. Good question. So to answer you first, I'll answer on the high level first. So we have 2 roadblocks in place, right? Number one is we have a design for manufacture tool that's taken the 2 million plus parts we've produced on 3D hubs and uses that to detect features that are going to cause issues with manufacturing. So we have this infinite feedback loop where if things get flagged, we can detect them, and we can be quite smart about what we think are going to be issues in a part. And we'll showcase that to the customer. So we'll say, hi, we think you're going to have issues with, say, thin walls. Then we'll highlight the thin walls on the part, and we'll say, if you want to proceed with this, it's kind of at your own risk. Alternatively, go away and change your design. This is where you need to change it, and then come back and upload, and you can put this straight into production right away. If they have an incredibly large number of errors, we actually block them from being able to order, and again, we give them feedback or direct them to articles about how they can alter their design to improve. Let's say they get a few warnings, but they decide to proceed anyway, which is the majority of customers. So the majority of customers will see a warning and they'll say, but I can still order. I'll just click the button and see what happens. Yeah. And they'll send it through. For CNC, on our CNC side, when we analyze that file, it'll typically go to one of our sales engineers or our salespeople who have a kind of training in manufacturing, and they'll identify that. So it's kind of roadblock from going straight into production again there. But 3D printing, it can go straight through. And some CNC orders can go straight through as well. And then it's up to our manufacturing partners to do the next check. So how our system works is we have a job board where you indicate the technologies and materials that you're able to produce parts with, and then we'll display all the orders that are coming in. You can observe those orders and choose to accept or decline them. And by declining, you're required to give us a reason, and it could often be manufacturability. So if we get an order completely declined, then that's picked up by our order fulfillment team. They'll reach out to the customer and say, hey, this order was actually declined by our manufacturing partners for this reason. Feel free to go away and change your design and update it. And that's a manageable amount. So our DFM's working. We've also, since our kind of shift to B2B, we've seen a big increase in the improvement in the type of customers that are engaging with 3D hubs. So back in the day, we got a lot of garbage. Now we're actually getting engineers who are really thinking about the design and are using this feedback to push it through. So yeah, those kind of roadblocks really help with that. That's not to say that still things slip through, but then we have a very clear agreement with our manufacturing partners that if you pick it up and you say you can do it, we expect you to do it, and we expect you to do it to these manufacturing standards. So they don't get penalized for declining. There's no problem with that. They can do that whenever they want. If they want to roll the dice and say, hey, you know what, this is tough, but I think I can do it, then we have a clear set of guidelines that they need to follow to make sure that that part complies. So yeah, the system organically kind of looks after itself there as well.
That's pretty cool.
So I have a little bit of follow-up on that, but before we get into it any further, let's take a quick break for a word from our sponsor.
And it's got to be 3D Hubs. We never, ever get sponsors other than whenever we're interviewing someone who could be a sponsor.
I think we're going to go with that. So Ben, could you give us a quick rundown of how people can learn more about 3D Hubs and how they could reach out to you if they have any questions?
Of course I can. It'd be my pleasure. So the easiest way to learn about 3D Hubs is to come to www.3dhubs.com on our website and dive on in. You can head straight to our checkout and just upload your parts. We have a range of technologies available: 3D printing, CNC machining, and injection molding. As soon as you upload your file, we'll give you an instant price and design for manufacturer feedback. You can select the lead time that suits your project, and with the click of a button, we can have your parts in production in less than 5 minutes.
That's awesome. And we actually have a special offer for our listeners. If you head to 3dhubs.com/podcast/unprofessional engineering, you're going to have the opportunity to download a sample of the 3D Printing Handbook created by 3D Hubs. Ben, were you involved in that creation?
That's correct. It was a tumultuous 6 months of my life, but we produced something we're very proud of. The irony of the 3D printing company making the 2D printed book is not lost on me. Don't worry about that. But yeah, our 3D printed handbook is really targeted at actionable design advice for engineers, designers. So it's not so much about the intricacies of how the technologies work. It's really, how do I design parts for each of the technologies, and the lessons that we've learned from all the millions of parts we've produced on 3D Hubs. We also had some amazing collaborators from some of the leaders in industry. So it is an awesome piece of kit to have on your desk. And your listeners can dive on in and have a look.
Awesome. And unrelated, I actually have a copy of the 3D Printing Handbook on my desk, and it wasn't just because of this interview. So I will vouch for it being awesome, and you should definitely go download the sample. If you like what you see, you can also then buy a full hardback copy of the book. So
yeah, we're on Amazon and in all the major distributors, so it should be pretty easy to get your hands on.
Yeah, we don't ask you people to do much. So how about you head over to 3dhubs.com/podcast/unprofessional engineering and download a copy of that. All right, so moving on, you were talking about your DFM software, so your design for manufacturing to determine if things are manufacturable. Is this a custom code that you're working with? Is it through a software company that you've partnered with? Because I know that's not exactly easy to do.
No, we have some very clever developers and software engineers here who actually, several of them are mechanical engineers as well, who decided to go over to the dark side, and they have basically taken all the lessons we've learned over the years. So for 3D printing, we're just taking all this data, and for CNC and injection molding, we're taking all the data and we're highlighting areas where we think there's going to be problems with manufacturability. So for 3D printing, this is things like thin walls or difficult to remove support areas. For a CNC machining, we're talking about areas where the tool might not be able to get to easily, even with 3 or 5 axis. And for injection molding, we do thermal analysis. So as you guys know, you've got to have, it's very important you have uniform wall thickness through an injection molded part to make sure it cools evenly. And so that's a big thing that we look for. Draft angles. So we're detecting these features in the actual solid models and highlighting them to our users if we think they're going to be an issue for manufacture.
So you just mentioned the users, so when I think of this service 5 years ago, this service feels very much, I want a prototype of something to put in my hand. And clearly, you're going away from that now with CNC and injection molding. And again, looking at your website again, like the numbers that you can produce in the amount of time, or that your partners can produce in the amount of time. Do you find people still using this as a quick prototype service, or is that a smaller portion of what's becoming more of just mainstream, this is now my supplier going through 3D Hubs?
Yeah, I think two main users on 3D Hubs. Number one, for SMBs, we become their supply chain manager, right? So supply chain managers are expensive, and for small and medium-sized businesses, they really kind of want to automate that away. And so a solution like 3D Hubs means we'll take all the risk as a company. You just need to upload your parts. We'll show you pricing straight away. You don't have to worry about material stock or anything. We'll do that with our network. So if purchasers and supply chain team members are kind of using 3D Hubs in that way to kind of take out that risk and say, okay, this is how I'm going to optimize my supply chain, because I'll trust 3D Hubs to deliver what they tell me they're going to. On the other side of that, we have engineers, product developers, these type of people who are actually using us to iterate their designs based on cost and design for manufacturer feedback. So going into SolidWorks, getting the, or going into any program that you're using for CAD, sorry, and getting the 3D model and then downloading the step, putting it in, seeing what the price is. Oh no, this is too expensive and I see I've got some problems with internal radii. Taking it back, quickly making some changes, downloading the step, throwing it back in and iterating the design until you get to a price point you're happy with, and then clicking the order button. So it has a number of benefits depending on really who's utilizing it.
So you don't charge. So let's say I have 10 designs, and maybe I'm giving this away, and I'm not supposed to say this, but let's say I got 10 different designs. I can upload 10 different designs and try maybe different materials, different volumes, and it's going to give me that feedback immediately on.
I would encourage you to. That's certainly how we want people to engage with our website.
Don't charge for that analysis of the cost versus material versus quantities versus.
Not at all, and we do it in less than 5 seconds as well. So as soon as those parts are ready, you bring them in, you put in all your design iterations, and basically select the one which gives you the best price point. And we've got economies of scale built into the website, all these types of things. So it'll do it all for you live straight away and really let you make decisions on the fly.
Luke, it kind of sounded like you had something in mind right there, huh?
No.
Getting a part ready for the taco truck or something?
So my lifelong dream of owning my own taco truck. I'm not sure if you have taco trucks in Amsterdam or not. But,
they have different kind of trucks. It's okay.
Maybe they have marijuana trucks, right? Amsterdam, right? Is that how it goes?
No comment.
No.
Yeah. No. Just my gears are going because I feel like. I feel like someone could use that and then not go with you guys and almost use that as a bidding process for like one of their local shops possibly. And I feel like my guess is your prices are pretty competitive, so that probably wouldn't happen. I would guess that's like what you guys do really well is make sure that your prices are the right price. But I feel like that's a great service to just offer up free of charge in my mind.
Yeah. I think one cool way I look at our product is we are the stock market for manufacturing, right? So we, when we're doing our pricing, we're really just taking data from all the parts that we've sold previously and seeing what the market was willing to pay and what our suppliers were willing to pay to make it, and putting all this information in to continuously update our pricing. So it's live and it's dynamic. And this means that the price that you're seeing is not some old guy in a workshop with a pen and paper figuring out like this cost of cutting the blank material, and then it'll probably take me about 3 hours to machine it, and then no, and then I'm going on holiday that day, so I need to add 1 day to the lead time. This is real data from all the parts that we've made, shown to our customers completely transparently, and we really feel like we're opening up what has been a black box in terms of manufacturing, and showing people, hey, this is the pricing, this is very, very open, this is how we do it. And what you're paying is what the person down the road has already paid for the parts. We're not upselling you or trying to add extra costs on. It's a completely automated and driven by an algorithm system.
So back when I started working with 3D Hubs, it was still in the maker community 3D printing space. Now that you have all these other options for manufacturing, what would you say the breakdown is from 3D printing to CNC to injection molding? Because, I mean, we might be able to prototype 3D, like by 3D printing here, but CNC machines and injection molding is a big investment.
Correct. Yeah. So 3D printing for us wins on volume. In terms of sheer number of orders, we do the most with 3D printing, but it has a lower order value, average order value.
Sure.
And then CNC machining has a higher order value. We do a few less orders on that. And then injection molding, there's a handful of orders, and it makes a much longer sales cycle. And we're generally involved a lot more with the product, the design, and the development with the customer, even though we can still show them instant pricing and design feedback there. And then by the end of the year, we're really going to be working to make that as quick as 3D printing and CNC. So the moment you click on it, it's basically a customer can have trust that whatever they see there, they click the button and it comes straight in, and that's is making injection molding as easy as ordering with 3D printing. So I think it's more so about the story behind how we kind of see people engaging with our website that's more interesting here. So as a customer, 3D printing is great for prototyping low volumes. It uses plastics. You'll come in, and if you just want to do a fit or form check for a part that you're working on for a machine or assembly, it's a fantastic solution. It costs you, I don't know, $30. You get your part in your hand in 2 days. There you go. Then you might say, okay, this fits. I need 50 of these. But I want them machined out of ABS. So I'm going to order this on 3D Hubs. I get more precision with CNC machining. They're really good at doing the lower volume, mid-volume stuff. And now I've got these production parts, and that's my mid to low volume production where I can actually get the part in and do some functional testing. Okay, cool. I'm really happy with this. It's performed well. Now it's time to go production. Let's go to injection molding with 3D Hubs. You have the same salespersons that work with you through the entire project. We're working with a system that you're familiar with, and each step of the way, it's just as easy as uploading your parts and clicking a button. And each time that happens, we've encompassed the full design cycle right up to production. And so these are these really cool stories where we have engineers and really product designers coming in and utilizing each of the stages, becoming familiar with distributed manufacturing, and seeing how quickly they can actually iterate to production using a system like this.
So quick question. You mentioned 3D printing, and when I think of 3D printing, again, 3-4 years ago, even just 2 years ago, I'm thinking ABS, PLA, some sort of plastic material. But what I've seen in the last year is tons and tons of metal printing, and I'm just wondering, is that something that falls into your 3D printing as an option, or is the price of that at this point kind of really not in the range for most people looking for those products? Because that seems to be the big trend in 3D printing, is direct metal printing.
Yeah, so two parts to this answer. Part number one, it's probably more the design than the cost that makes something suitable for 3D printing in metal. So of the thousands of potential designs I've seen come across my desk, only a handful are actually suitable to be used on a 3D printer currently. It's a very complex technology. It's very expensive if you get it wrong. It needs support material that's mechanically attached to the build plate. You need to do a lot of cutting. Often there's some post-processing. And certain geometries just can't be printed. It's just, they're just very, very difficult. Even though that is one of the benefits of 3D printing in general, it gives you a bit of design freedom. And so we often see the ability to upsell these people to, not upsell, but actually change their technology and go to our CNC offering. And that's generally what we do with a lot of the metal 3D printing solutions there. The other side of that is that there are a few other alternatives to metal 3D printing that have come out over the last few years as well that aren't just your DML, SLM type printing. And things like Desktop Metal or Metal X are now using the FDM technology with a filament that's got metal fibers, metal powder inside it that's then held together with a binder and is burnt out and the parts are sintered. Is a much cheaper option than some of the other technologies and still gives you robust, cohesive metal parts. These are kind of making a bit more noise in industry as well. So that's an industry that's developing. I think the big issue right now is that people are using it for the wrong things, and they kind of expect that you can metal 3D print anything.
Yeah, that was my assumption.
But when you find a fit for it, it is incredible. So aerospace industry has cashed in on this big time. You see a lot of noise coming in automotive. It's perfect for medical, dental in particular. It's really, really common and highly customized parts. So when it fits, it works really well. And this is almost the story of 3D Hubs and 3D printing in a nutshell. When you find a spot, it is so disruptive. But right now, it's kind of in these little pockets. I think metal 3D printing, as the technology becomes better, as material prices go down, as machines become more common. I mean, I think there's only less than 400 metal 3D printing machines in the world.
Wow.
Then this is just going to be a technology that's going to take over. And I think give it 5-10 years, it'll be a very, very competitive method of manufacture. But right now it's still kind of caught in the niche, but it's not brand new. That's the other thing to highlight. It has been around for a while, and people are getting smarter about how they're utilizing it.
There have been a lot of cool stories that have come out about like the auto industry or aerospace or whatever that have been 3D printing cool parts. And it kind of feels like some of the parts are even one-offs or as kind of like a prototype to show that it could work or a proof of concept. But now I am seeing more and more where something in the auto industry will take an assembly that was, say, 9 parts, and now it's being 3D printed into one. Lighter, cost-effective, stronger. It's amazing.
The part consolidation is the coolest thing. Like, sure, it can do all these organic geometries and everything, but I'm an engineer, and part consolidation really excites me. And there are some great examples of satellite parts that were, I don't know, 1-2 feet cubed that were being brought down to fit in the palm of your hand. They were 100 parts. They're now printed in one. So, I mean, there's some really, really amazing examples of this. And I think that stuff excites me a lot.
That was such an engineering thing to say. Like, that's what an engineer says. Man, the part consolidation really excites me.
My closet nerd pokes his head out every now and again.
So speaking of complexity, getting to CNC now, you guys do all the axes? You guys doing 2, 3.5, 5? I mean, I guess it depends on the partners you have. It could be anything it needs to be, correct?
Exactly. Yeah. The majority. Oh, sorry. We have 5 axis certainly, and a lot of our suppliers have access to those machines. So yeah, there's certainly something we can offer.
That's awesome.
I think the website should just say all the axes.
Yeah, all the axes. That's a great sell. Everything on the menu. Yeah.
So I only have a few more questions here, but this one just came up a little bit ago. What do you do with the molds from injection molding once they're done? Do you save them in case people come back for more? Like, how long do you hold on to them? Because those aren't cheap, it turns out.
No, it's true. And they're usually a big upfront investment from the customers.
Oh, yeah.
Our manufacturing partners will hold on to the molds. They're usually proprietary for the machines that they operate. So often there's no point in sending them to the customer. And we really want the customers to come back to 3D Hubs to order their parts again. So if they want to do that, we'll maintain the mold for them for 2 years. And they can come back and reorder the parts anytime. It'll go straight into the machine, and you can get a 1-2 week lead time for your injection molded parts if you've ordered with us in the past.
All right, so we're running out of time here. Luke, do you have any more questions that you wanted to ask?
So if you could look into your 3D Hubs crystal ball, what do you think the next year and a half, 2 years looks like for you folks from a not just growth of the company, but the types of things that you do for customers? So if you're allowed to say that, maybe that's some kind of proprietary.
I don't know. I certainly can. This is probably some of the most exciting stuff. So distributed manufacturing as a concept, I think, is still quite foreign to people. And a big thing that we try and do is build trust. So we want to build trust that when you come to our website, you're actually going to get parts. They're actually going to be delivered. And I kind of compare this to, think about the first time you told your mum about Uber, and she would probably be very hesitant. She's, what do you mean I hop in someone's car? I'm not hopping in a stranger's car. Yeah, exactly. Or, oh yeah, Airbnb, great. I'll go sleep on some weirdo's couch. Who's really do that, right? So, and now this is commonplace anytime anyone go anywhere. So this is a big part of how we're trying to build. We're building trust in the industry and getting people to understand that. And a key part of that is just exposure and coming in and trying it and see that it works successfully, and then that we can actually deliver on what we promise. After that, there's a raft of possibilities, but I kind of have my dream scenario. So 3D Hubs is integrated with some type of CAD software, and it's a generative tool. So you put some points on, you maybe put some loads on, and you generate, let's say, 10 to 15 designs on your computer. Each of them are displayed on 3D Hubs, and they have the instant price shown, so you can see the price for all 15. You can see design for manufacture for all 15. You can quickly, as an engineer, make a decision on what part you think is best for you to manufacture. With a click of a button, it goes into production in 3D Hubs, so you know what the pricing and everything's going to be. And that fires off to our manufacturing partners. They have an algorithm which analyzes all the part jobs that are coming in and selects which ones are most appropriate based on scheduling, capacity, what material stock they have available. And for 3D printing, it automatically turns the printer on and starts printing it. No human interaction needed at all. For CNC machining, you've got a robot that goes over, unloads a standard blank size of material, puts it into the 5-axis machine, and that fires up and starts machining as well. All the machinist needs to do is just walk over with his cup of coffee and maybe have a look. And this also integrates with an algorithm-based CAM software, which is actually automatically plotting the toolpath for parts. So CAM engineering kind of let's automate that away as well. The moment the job's finished, it's loaded off the bed and put in front of a 3D scanner. The entire part is scanned. All this information is continuously fed to the customer. So the machining stage has started, and there's a video of the part being machined. The 3D scan stage has started, and you see the scan happening, and you get instant feedback on whether it's a pass-fail compared to the 3D model. It's then picked up off the 3D scanner, loaded into a box, and sent off to you, and you can track every single step as it's actually coming along and live track it as it comes up to your workshop door. You meet the drone that's delivering it at the front door, grab the box off them, and away it flies, and then you open up your parts and install them onto your machine. And all this happens within a week from the moment you wanted to put things on. For 3D printing, let's say you could get it in 24 hours. For CNC, let's say less than 5 days. This is where we're heading, and this is what we're building our software around. So we're not only really focusing on optimizing our part of the chain, but we really want to see what are other people doing that we can align with and we can partner up with or we can acquire that are going to help us do everything from the cradle to the grave production of this product. And so that's what excites me about this, is just really the opportunity to completely disrupt, which is a very old school industry.
Very ambitious. I like it.
And how far away is that again?
Let's say we're going to try and do it in the next 5 years.
All right, that sounds pretty good. If only I knew any company you could team up with for that first CAD part. That would be really interesting.
Yeah, I've seen some pretty cool generative design packages actually around. I think you guys are pretty familiar with it, actually.
All right. Well, I think we're about out of time here. So, Ben, thank you so much for joining us today. I learned a ton, and I might have to head over to 3D Hubs a little bit more to just kind of poke around and maybe send some people your direction.
Yeah, that'd be fantastic. And guys, thank you. Sorry, you got
my taco truck future is within reach now. I just got to get it 3D printed.
I mean, occasionally we do get entire things like trucks or cars uploaded to our website, and someone says, "Please just machine this entire car for me."
Can you just make this?
We do see those coming along. Give me a few years, Luke, and we'll try our best to get your taco truck machined in one single step file.
Beautiful. All right. And one more thing, if you did want to learn more about 3D printing, either for your Yoda heads that you're printing at home, or maybe if you're actually looking how to better implement that into your manufacturing strategy, head over to 3dhubs.com/podcast/unprofessional engineering, and you can download a free sample of the 3D Printing Handbook. Help us all out and go get your copy. So once again, Ben, thanks a lot for joining us today. And hopefully everybody's learned something.
Thanks, guys. I love the series, so very proud to be part of it.
Thanks.
Thanks. Bye now.